Good evening, Cappuccino. Yes, it has been a very long day here at the Castro household in Mill Valley, California, because my power went out. Wouldn't you know, during the middle of a epidemic, I would have my power go out. So it is now on, and it is like 9:20 at night, and why not make a warm-up for today? So first of all, I wanted to tell you I'm going to go over the answer to the previous day's warm-up, yesterday's warm-up, of which Izzy was the winner of the 10 points extra credit. I think I gave some other people 5 points extra credit. By the way, I haven't put it into your scores yet, so you can remind me tomorrow if you still don't see it in one of your math space assignment scores. You should see a really nice big bonus in your math space scores. So here, though, is the new warm-up, week 11, day 3 of the epidemic. On a television channel, the news is shown at the same time each day. The probability that Salia watches the news on a given day is 0.35, or 35%. Calculate the probability that on 5 consecutive days she watches the news on exactly 3 days. Okay, so this is like what you were doing yesterday, right? Because you didn't do anything today because I was busy trying to get my power restored all day long. So first person who gets me the correct answer to this, 10 points extra credit. And let's say the next 3 people who give it to me correctly will get 5 points extra credit. Okay, so 10 points for the first person and 5 points for the next 3. Next 3 correct answers. Okay, I'm hoping you can all get this one after having done that math space assignment. All right, back to this one. This was kind of a 2-part question here. First of all, a player rolls a 4-sided biased die, so that's kind of weird to begin with, but that's just a die that instead of landing on 1 through 6, lands on 1 through 4. We know that in a probability distribution, all the probabilities have to add up to 1, so I can go ahead and solve for k here by saying, okay, 1/3 plus 1/4 plus k plus 1/5 has to equal 1. Let me get a different color so you can see this better. I need a common denominator to add my fractions here. I'm not going to change these to decimals because 1/3 is a nasty decimal. So let's see. I think I can change these all to, what, 60? I think I can change these all to 60. Maybe I could do better than that. Let's see. I did this problem before. I'll change them to a denominator of 60. All right. So 3 times 20 is 60. So this would be 20/60ths. 4 goes into 60, oops, sorry, that should have been a 60. 4 goes into 60 15 times, so this would be 15/60th, plus k, not going to worry about that right now. 1/5, 5 goes into 60 12 times. All right, so now I have a common denominator, so 20 plus 15 is 35, 35 plus 12 is 47. Okay, I'm going to bring it down here now. 47/60ths plus k is equal to 1. I'm going to go ahead and write 1 as 60/60 so that I can now subtract my 47/60ths from both sides. So k is equal to 60 minus 47 all over 60, which gives me 13. So k is equal to 13/60ths. All right, so now find the probability of rolling twice and getting a sum of 4. So when I think of a sum, if I'm going to be adding these die together, that kind of reminds me of a table. I think I want to make a table, and I'm looking for rolling a sum of 4. So I think there's a couple of ways that I can roll a sum of 4. So I'm going to go ahead and set up a table for this to help me out. So I could roll a 1, a 2, a 3, or a 4, or I could roll a 1, or a 2, or a 3, and I should have extended those lines, or a 4. Okay, so now where can I get a sum of 4? I'm actually just going to circle where I'm going to get a sum of 4. If I have 1 plus 3, that would give me a sum of 4. If I have 2 plus 2, that would get me a sum of 4. And if I have a 1 and a 3, that would get me a sum of 4. So in order to get that sum of 4, I need to get both a 1 on one of the die and a 3 on the other. So the probability of getting a 3 is k, and I now know what k is. K is 13 over 60. And then I'm going to multiply that by the probability of getting a 1, which is 1/3. So this one right here would be 13 over 60 times 1/3. Let's get a better color. That's starting to get hard to see. So I have this option, 13 over 60 times 1/3. But this one also makes me a winner. So getting a 2 on one die and a 2 on the other would be 1/4 times 1/4. 1/4 times 1/4. So I'm going to add that to the first probability. So 1/4 times 1/4. And then the third opportunity here is getting 1 and a 3. So 1 is 1/3. It's the probability for that. And the 3 is that 13/60. So I'm going to add, running out of room, 1/3 times 13/60. Okay, these are all some pretty ugly fractions, so I am actually probably going to give the answer as a decimal, I'm thinking. So 13 times 1 is 13. 60 times 3 is 180, plus 1 over 16, 1/4 times 1/4 is 1/16, plus 13 again over 180. See, those are just ugly at this point. So at this point, I would say calculator time. IB would not expect us to add that ugly of fractions. Oh no, look, power outage everywhere, even on my calculator. Let's see if it'll do it for me. So 13 1/80 plus 1/16 plus 13 1/80 gives me 0.207 if we're talking 3 sig figs. If you change it to a percent, it would be 20.7%. Okay, so that was the warm-up from yesterday, and again, Izzy was the winner, getting that in first. So let's see who gets me this one first. It is Wednesday night right now at 9:30. So yeah, if somebody gets it to me tonight, they are the winner. So on your mark, get set, go.